technology. We appreciate your patience. We want to welcome you all today to Mission Predictable, the live judging and awards ceremony for this hackathon. We're super excited to have everyone here today. Oh, there we go. So myself and Sapphire are the fellows at Women Who Code in the data science and blockchain tracks. If you want to say hello, Sapphire.
Hi everyone, I'm super excited for the live judging and award ceremony today. It's been so good organising it the last few months with Naomi, Kesha, and also Sharon has helped us a lot there too. So I'm excited to get started and see what all the teams have produced, because the amount of teams that submitted really good projects is outstanding. So congratulations to the top 7 and all the teams that have participated.
Yeah, we've been absolutely blown away by the quality of the submissions. It was a really hard decision, and we're really looking forward to seeing the presentations today for the finalists. At any time, if you want to reach out, Naomi at womenwhocode.com. These events don't happen without the rest of our track. We have an extraordinary team in data science working to make this happen. Helena will also be running a quiz later today, and Aram's been helping with the submissions review. But it takes the whole entire team to make events like this happen. We also have a special coordinator today that you've probably seen in and out, Mr. Tor Haven. He is helping our teams get ready, get presented, running IT, just, providing some extra hands, and we're super, super, super grateful. My slides won't go. Here at Women Who Code, our mission is all about inspiring women to excel in technology careers. And our vision is really a world where women are representative as technical execs, founders, VCs, board members, software engineers. Anywhere in technology where you find people, we hope to see women represented there. Right now, we have 230,000 members across 70 networks in 20 countries. If you go to womenwhocode.com, there's great access to jobs, the job board, as well as other resources. We hope you all are able to chat and connect today in the Zoom chat and continue those connections after the event. Our movement, especially now as the world changes, is to be a connecting force that creates a sense of belonging while the world is being asked to isolate. And the camaraderie and teamwork that I've seen, not only within the teams at the hackathon, but also between teams in supporting each other to get to the finish line, has really been exemplary in this sense. Here at Women Who Code, we do have a code of conduct. It's an inclusive community. We want to make sure that everyone is in a really good, safe space. If at any time you feel that there is something you would like to let us know, womenwhocode.com/code of conduct. You can submit reports there if you feel that someone is creating a less safe space. You can get involved and volunteer to help make these happen. Our next onboarding for volunteers in data science is August 25th. So feel free to reach out, fellows at womenwhocode.com, and let us know that you would like to volunteer with data science. And then we're going to kick off this hackathon. I know you kind of put this together, Sapphire. Do you want to talk a little bit about what was going on this summer? I know Kesha's going to kick us off in a moment, so.
Yeah, sure. So I put the slide together just so everyone can kind of know what we've been up to the last few months. So Kesha started off with 3 workshops, and we had a lot of participants that got involved there. And afterwards we started up the hackathon. So we had a lot of teams that after the workshops, they've learned a lot from what Kesha taught them, and they participated in this Mission Predictable hackathon. And the teams had 3 weeks to come up with their projects and build their projects. So that was 3 weeks they had. and they had two rounds of judging. So the first round was last weekend, so the teams only found out on Monday there if they got into the final round, and this is the final round today. So yeah, so well done to all the teams that got into the final round.
Yeah, that's great. And then we're going to allow Kesha to grab the screen here, providing we have picked the right Kesha as co-host.
Okay, I'm going to try and share my screen. And then present my slides. Do you all see my slides?
Yep.
Okay, awesome. So I'll go ahead and get started. Hello, my name is Kesha Williams, and I am so super excited and thrilled to be here. When I had this idea to take others on my personal journey to use machine learning to battle COVID, I had no idea, literally, that it would turn into all of this. A 3-workshop series on machine learning and a full-blown hackathon. And just to quickly tell you a little bit about myself, I've been in IT for about 25 years. I've served in various roles: software engineer, software engineering manager, technical lead. I currently work for a company called A Cloud Guru, and I'm also an AWS machine learning hero. And anyone that knows me, they know that I love sharing my lessons learned with others to just give people a jump start and to make sure that they don't make the same mistakes that I've made. First, I want to give a huge shout out and thanks to the Women Who Code data science team for helping me bring this idea to life. From graphic design, marketing and promotion, agenda planning, judging criteria, and just helping review the submissions, I could not have done this without your support. So a huge thank you. We had a total of 3 workshops and 686 registrations for those workshops. We had 211 people register for the hackathon, and we had 52 teams to join in. And I was totally blown away and so proud of all of the submissions. They were all awesome. We did have a tough choice, and we could only pick 7 teams to move to this final round. And like I said, it was a hard choice. The 7 teams, they have all used machine learning to battle COVID in very creative and unique ways, from vaccine development to predicting infection risk, to predicting intubation, classifying X-ray images, categorizing risk level, and determining why Black communities have a higher risk of death. So congratulations to the 7 teams and good luck today. And did I mention we have some awesome prizes for the winning teams? A big thanks to AWS for allowing us to have $5,000 in AWS credits to each member of the winning team, and also for giving us the $200 per person workshop credits to help us on our learning journeys. And then a huge thanks to A Cloud Guru for the 1-year free membership for each member of the winning team. And that's going to help you continue to learn about machine learning, explore the cloud, and explore AWS. So a huge thanks. And a huge shout out to our amazing judges today. We have some impressive judges, and judges, I'll tell you now, I would not want to be in your shoes because it is going to be a tough decision. So Katie, Ali, Sahika, Adrian, Sally, Naomi, and Sapphire, thank you all for being here, and thank you so much for your support. And wow, do I have a special treat for you. one of my sheroes, literally, Sandy Carter, Vice President at AWS. She is a true role model for women in tech and someone that I have a lot of respect for. She's authored 5 books, won many awards. She's the chairman of the board for Girls in Tech and Women in Technology International. She's a professor at Carnegie Mellon and the founder and CEO of Silicon Blitz that helps startups with technology and innovation. And I just think to myself, I thought I was a busy person. I don't know how she finds the time. And a really cool fun fact about Sandy, she is fluent in 8 programming languages. So I just want to thank you, Sandy, for being here. And now I'm going to turn it over to you so that you can offer us some words of wisdom.
Well, thank you, Kesha. I think I'm your biggest fan as well. I love you and I love Cloud Guru. So thank you guys so much to be here. I see some of my other great friends on the chat, Allie and Adrian. I mean, you've just got some rocking women here, which I think is really going to make a huge difference. I just prepared a few slides that I'd like to share for a moment. A couple of messages that I think all of us can hopefully relate to. And I call this kind of change the world. I only have 5 minutes, so I'm going to tell you how to change the world in 5 minutes. That's pretty darn cool, right? I've included my Twitter handle here, and if anybody wants to reach out to me, I am more than happy to help any of the talented women on this call with anything that you're working on. I want to do a huge thank you for the honor of being here for Women Who Code. I always look at what they're posting, what they're doing, because they are changing the world in a very special way. So thank you, Naomi and team, for inviting me to come and participate today as well. Really appreciate it. So I'm going to start out with a little joke on innovation. And I don't know how many of you have children. I have 2 daughters. And we have traditions. I don't know about you guys, but we like to kind of do Pizza Friday, and then we do Pancake Sunday, and I make the pancakes. So one day, my daughters brought me this picture, and they said, "Mom, can you make us this pancake?" I said, "Of course I can make that pancake. How hard could that be?" And of course, you're probably laughing, as I did, but my daughters didn't. So I learned a couple of interesting lessons from this little personal experiment. First, innovation takes time and experimentation, right? This is an experiment, an MVP, if you would. Typically, an MVP hasn't really worked through the user interface. So my user interface needs a little bit of work, but I nailed it because I worked backwards from my customers, and my daughters both ate it, and much to my chagrin, posted this all over Instagram with the great pancakes that their mom had made them. I share that with you because what you guys are doing today is you're experimenting. You're doing this hackathon. As Kesha said, you know, you guys have done some amazing things in this amount of time. And I'm sure that it's not perfect, but it's something that is really going to disrupt and innovate in the marketplace. So one of the principles that I always live by are leaders are never done learning. They always work to improve themselves. And in fact, I love quotes. And one of my very favorite is this: "I have no special talent. I'm just passionately curious." Do you know who said that? Albert Einstein. Being curious, always striving to ask the right questions and really look at the new possibilities is one of the biggest things that you can do in life, whether that's with your kids or your family. In business, being curious and asking questions is always a great way to discover new ideas. In fact, I bet for the 7 winners, they all started with some interesting question that they wanted to think through. So I love technology. And if you think about this and framing technology, all of you guys are looking at machine learning and AI today. You've got this challenge. In fact, Kesha, I thought it was Mission Impossible, and then I read Mission Possible. I thought this is really cool, right? Because what we're going to try to do is bring together this thought process of machine learning and asking questions. You're going to bring in data from IoT. You're going to use analytics. You're never going to stop learning or just looking at one technology. This is really going to branch you out into several different areas. And so as you think about that, you have to keep asking questions to get to the right question. And what does this mean? A friend of mine wrote a book. It's called The Creator's Code. And because I was at Carnegie Mellon, I got to help her with some of the research. And she got to interview all of these amazing innovators, Jeff Bezos, Steve Jobs when he was alive, Elon Musk. And one of the things that she found that was common among all of them consistently was that they ask a lot of questions. And she went on and she did more research, and she found that kids, and if you have kids, you know this, they ask on average 100 questions a day, 100 questions a day. But the average adult only asks 10 questions a day. But the Jeff Bezos, the Elon Musk, the Steve Jobs ask 100, up there with the kids. And that's why they're innovating and getting to these new ideas, because they're asking the questions over and over again to get to different answers. Let me show you an example of this. So I know that Kesha, I know Allie, I know everybody's probably going to go, yes, Deep Racer. If you don't know about Deep Racer, yeah, awesome. It's an educational device. It is a car that's 1/18 the size of a real race car. It's got those IoT sensors on it, and you actually learn reinforcement learning for machine learning in a fun way by racing a race car around and teaching it how to stay on the right journey, on the right path. But do you know how this came about? Customers were asking us, we need more training because we need more people like Kesha. We need more people who know machine learning. And so we could have said, okay, so people are asking for learning. So the obvious answer is, let's create more classes. Let's create more Keshas. Let's get more cloud gurus. But as we kept asking the question, we said, you know what? In order to meet the demands that are out there, we have to think differently. We have to answer the question differently. And we have to say, how can we put machine learning in the hands of every developer? Not just a few, but every developer. And that's how Deep Racer came about. Asking question after question after question versus just putting class after class after class out into your curriculum. I love this example because it really teaches you that you have to ask some of the basic questions to get to the big innovation that exists out there in the market. So as you guys know, with COVID, I love the fact that you guys are using machine learning, I would say, to crush COVID. It's changing the way that we work forever. But I love the mission of Women Who Code, because part of my vision, Kesha, is not just to have machine learning crush COVID, but to have women tech leaders elevated, to have them recognized for the work, to have them recognized for how they are changing the world. Now, this next slide, it will be funny. When I show it in presentations, people laugh. But to me, it makes me really sad, actually. This was from Fast Company. And they asked and surveyed a lot of people. And they said, name a female tech executive. Anyone, just name anyone. Only 3% could accurately name one female tech executive. A lot of people said Alexa or Siri. Believe it or not. However, whoops, Alexa off. Sorry, my Alexa started going off. But in contrast, almost 60% of them could identify a male tech leader. We have to change this. We have to change this. And that's why I was so honored when Women Who Code invited me to come and speak. That's why I love Kesha's vision to have machine learning crush COVID with you guys, because you guys have that technical skill to really rock. And so what I'm looking for is when this survey is done next time, that they name Adriana, they name Kesha, they name Naomi, they name Allie, that those are the women technology leaders. And hopefully they're going to name one of you 7 to be running the next billion-dollar unicorn company as well. Because what I know you guys are going to do is completely change the world. And with that, I'd like to kick it off and hopefully have inspired you to not just make a difference today, not just win this contest, but to really help us to change the way people are viewed throughout the world. Women are viewed. So I am going to include my email address here. People always gasp when I do this because they're like, you're going to get that 5,000 emails. But I do this because I want to help the next generation of women leaders. I want you guys to get recognized. Don't overanalyze it. Get going. And good luck to our 7 contestants. And my congratulations to the winner, whoever that is. And best to the judges as well. Thank you guys very much. Appreciate it.
So I will be saying thank you to Sandy, especially for taking her time to participate in this. I know she has a busy schedule, so like we really appreciate that. Again, I would like to thank Sapphire and Naomi from WWCode who gave me the opportunity to jump on here and support you guys with all of the logistical parts. I know it's been a learning curve for everyone. I also want to thank the judges, the Katie Bullard, who is the president of A Cloud Guru. We have Sarka Junk, who is a principal applied scientist at AWS. We have Sally Ravel. She is the head of AI product marketing in AWS. So the theme is AWS here. We have Adrian Cockcroft, who is the VP Cloud Architecture mumbling words there, sorry. VP Cloud Architecture Strategy at AWS. And we have Ali K. Miller, who is the US Head of AI Business Development, Startups and Venture Capitals at AWS. We also have the mentor and who's been running a lot of things in the background here, Kesha Williams. So thank you to her as well. She's a training architect, a cloud guru at AWS and machine learning hero. So basically what we're going to be doing now is we're going to share a slide here. I just need to find the right one. So we're going to start with the presentation time. So I hope everyone is ready. And the team we're going to start with kicking off here is going to be the architects. So whenever you guys are ready, the architects, just jump in and share your stuff.
Thanks for the introduction tour. It's a real pleasure to be able to present our project today. We're the Architechts. The Architechts team consists of 5 engineers. Myself, I'm Mary Jane, Claire Houston, Lauren Burns, Claire Byrne, and our 5th member, Chloe Thompson, who won't be presenting today, but I think she's watching.
So we're going to take you through our dataset discovery, our idea generation and problem specification, the data analysis, the training, the testing that we took to create our machine learning model, our finished product of our deployed website, and finally our next steps and the societal impact we've made. So our initial idea, we found that we had to actually pivot from it, involved COVID testing and pulling, but we couldn't actually get granular enough data to do it. So we looked and found a new data set that actually provided us more and better information. It included details around obesity, asthma, and critically, intubation. We all know that COVID causes terrible, terrible effects when severe. It causes respiratory illness, and when that is at its most severe, it requires intubation. Due to localized spikes that we've seen across the world, this can cause issues with intubation equipment and shortages on it. So our goal is to create a website that allows us to deploy a machine learning model that tells you the likelihood of someone requiring intubation and give it to medical professionals. It'll be based on factors such as gender, age, and other pre-existing conditions.
So once we had our data set loaded into our notebooks, our first move was to use various visualization tools to investigate any interesting trends that we could find in our data. So some of the trends that we found included pregnancy having a negative correlation to being intubated, comorbidities having a positive correlation to other comorbidities, and being an outpatient having a negative correlation to being intubated. And by comorbidities, I'm referring to the presence of one or more additional conditions that often co-occur with another primary condition. And another interesting area that we investigated was the impact of a pre-existing lung condition on an individual's likelihood of intubation. And this particular data visualization became really relevant to our final model. So as you can see in our graph, those who didn't have any factors had the lowest chance of intubation. Pneumonia led to a higher chance. Tobacco and COPD led to a partial increase. And most interestingly of all, asthma actually seemed to not increase your chances of intubation.
So onto the technologies we used then. We used Python 3 and React.js as our main development languages, alongside many different AWS technologies. So SageMaker for our data science modeling and execution, API Gateway for mediating data to the website through a Lambda, and finally S3 to store our data and host our website, which is live. So this is an architecture diagram of our application, and the flow goes like this. An end user, such as a doctor, submits patient data into a web form. The data gets passed through API Gateway, which kicks off a Lambda, passing the data to our model endpoint in SageMaker and processing it against thousands of anonymized patient records. The result is then passed back through the pipeline and displayed on the site. So we performed our initial model comparison locally on a subset of the features using scikit-learn's logistic regression and KNN algorithms, evaluating for optimal results. Our model was initially biased, as most models are, so we evaluated and rebalanced our dataset and got far more accurate results. So we finally selected SageMaker's linear learner algorithm to train, test, and deploy with, because it best fit our dataset and architectural requirements, enabling the model to be accessed via an endpoint.
We have a short video here to demonstrate our project in our slides, and there's also a hyperlink in the slides to the live site. We created this website as an interface to highlight how you can interact with our machine learning model. The website has a number of simple inputs that the user is prompted to enter, after which they are given a message that indicates whether intubation is likely or unlikely. The website was designed to be simple and responsive. Our project would have a positive social impact by enabling better forward planning and less stress on the medical supply chain, as we were able to predict ICU numbers and reroute resources to the places that need them the most, potentially saving lives. Also, the model is extensible, so we can potentially discover unknown risk factors without necessarily having to conduct a long-term study. There are 3 areas of improvement that we would like to work on next, including we would like to implement AWS Poly to minimize virus risk transmission. We would like to improve the accuracy of our machine learning model. And finally, we would like to implement a dashboard that can provide hospital staff at a glance with data that can help them make more informed decisions. And that is our presentation. So if you have any questions, let us know.
Thank you, guys. Yeah, we've allocated a couple of minutes for a question round. So if any of the judges or participants have a question, feel free to just ask the team.
I have a quick question. How do you think about causation versus correlation? And did you find anything in your model that you would say was just correlation versus causation?
I'll jump in. Was just causation, sorry, versus correlation? Sorry, I was going to give an example of the something that we found that outpatients, for example, had a negative correlation to being intubated, which would make sense, seeing as they were physically outside the hospital and therefore couldn't be intubated. For causation, I think an example of that would probably be the tobacco that we saw, as you can make the case for pneumonia. I suppose pneumonia would be a good one for requiring intubation quite quickly, but tobacco could maybe worsen it over. It is something that comes along a bit later, where tobacco would be an earlier cause of increasing the risk.
Great. Thanks, Claire.
I have a question. Can you talk a little more about the linear model that you used in SageMaker?
I can jump in for that again, unless, does anybody else want to jump in? Cool. So yes, so I think, so we selected the linear model as we wanted to kind of make the most of using SageMaker's own algorithms. So we did an initial assessment using scikit-learn's KNN and logistic regression, and we got pretty good accuracies with that, but we felt that by kind of leveraging the actual model, it would allow us to faster get up and running with deploying to SageMaker, but also that it would give us kind of an effective use, as we felt it would be the most suited comparatively, instead of the likes of XGBoost, for the data set and the factors that we were actually feeding in to train our model.
Thank you.
Are there any more questions?
I've got a question. Have you reached out to sort of medical professionals to figure out, and have you got anyone using the site already?
I'll step in here. No is the short answer. No. So our focus was kind of to build a proof of concept first, but if we were to carry on with this, doing user research and really getting people in the field to use it, especially to test the responsive elements, and using it on portable devices and things, and that would be definitely our next priority, is making sure that the interface works for those that are actually going to be using it out in the field.
Okay, thank you.
Okay, then I don't think there is any more questions there. So we're jumping on over to the next team, which is going to be Sharonda and Omega. So once you two are ready, just start it off.
Hello, Tor. Can you hear me okay?
Yeah, I can hear you.
Okay, terrific. Then we will get started.
Great.
Well, Team 6 is represented by Omega Marcos and myself, Sharonda Pettit-Warner, and we are very excited to participate in this hackathon to battle COVID-19. Our mission was to gain some additional insights into why COVID-19 was disproportionately affecting African Americans in the United States. Our problem statement was based on the fact that Blacks are dying at a rate higher than all other races in America. The death percent for Blacks is 22%, while the share of the Black population is 13%, as depicted in the diagram below. Our goal was to use machine learning techniques to uncover insights into the why and find out if disasters do discriminate. The technologies and models that we leveraged and used, we used Python programming language, performed our data visualization using Plotly so that we can drill down interactively into our data sets. We used unsupervised machine learning methods such as PCA, a dimensionality reduction technique, K-means clustering. Our machine learning approach included demonstrating the following tasks: how to build PCA and K-means clustering training models using sklearn libraries, as well as how to build and deploy these training models using AWS SageMaker. Our team analyzed COVID-19 policies, cases, deaths by state and race using the most recent US Census data for a total of 18 data files, 246 attributes large. We reduced the attributes into 5 PCA components using Amazon SageMaker pre-built algorithm. We examined the makeup of each of those PCA components based upon the weightings and the original features. And what we found, as you can see in the diagram above, that in PCA 3, the attributes describes the states that had what we were looking for: high Black deaths and cases. In addition, it revealed other information to us as it related to the reopenings, the mandates, income levels, below poverty. We took all of the PCA components that were built, we named them based upon the features that they exhibit, and then we combined the PCAs with clustering using Amazon SageMaker k-means to cluster characteristics of the different states and then segment those into groupings. In the graph above, you can see that we plotted a heat map of those clusters against the PCA components with the focus on PCA 3. We evaluate the insights of each of these clusters, centroids represented in terms of the PCA components. From our cluster analysis, cluster 2 had the highest Black deaths and cases. And the key findings and the features that we found in these clusters are as follows. We saw in this cluster high % unemployment, high at risk for serious illnesses due to COVID-19, high households with income below poverty level and living under the federal poverty line, second highest % population with no health insurance. This segment cluster, they ended their stay-at-home policy earlier and participated in the reopening mandates earlier. They had the lowest % of households with internet at home and the lowest to no paid sick leave. So our social impact message is this virus is killing African Americans. Our analysis reveals a link between race, poverty cases, and deaths in America. So, do disasters discriminate? We say yes, by government policies and by socioeconomic issues. And you can see by these policies and issues where our features map to. Our solution is a call for a national policy. Since this is an infrastructure issue, we need a policy on healthcare and dealing with income inequalities, which include protective policies for workers, paid sick leave, provision for health insurance, and closing the income inequality gap. During the pandemic, we should be increasing access to testing, PPE, and education, and support for food assistance, and making available relief funds to the communities that are most in need, and collect a lot more COVID-19 data by race. Our next steps, we would like to continue to do the data mining on more data sets and rebuild our model once we have that data available. We also discussed building a SEER model for forecasting the spread of disease in high-risk communities. So with that, we'd like to thank the Women Who Code for putting on this code challenge, Amazon Web Services for providing those wonderful credits, and Kesha Williams for being a mentor as well as our cloud guru. With that, Omega and I welcome any questions you have on our project. Thank you.
I'm going to clap because I'm going to jump in with the first question because I know everyone else is going to want to ask one. Fantastic presentation, Omega and Sharonda. This is great. One of the takeaways that I love from social impact, and like here is, you know, the action that we need to take, is often highlighting the features that did not contribute to the difference that you labeled, right? So what did they over-index on to be really high? What did they over-index on low? Could you share a few variables that did not really get highlighted in that k-means clustering and what you saw as a non-differentiating factor?
I'm just going to go back a little bit.
Yeah, great.
Okay. So here is the PCA components that we looked at. And so our focus was on Black deaths and Black cases. So I think initially when we went into it, certainly we were thinking about things like unemployment being a factor, but some of the things that I think we thought that didn't make it would be things like, I don't know, Omega.
High income, like most of
yeah.
most of income here is that related to income. So we have a lot of data sets related to high income, and like density, like population density is the lowest density. You see a lot of population density, high income. So income is a lot of things that we don't see on these things.
Definitely population density, because we were looking at that as being a key factor for the data set that we were looking at. But that didn't come up.
Great, good highlight. And thanks for the work.
Thank you.
I have a question. Maybe this is related to Ali's question. You mentioned you had 18 data sets or data sheets. Can you talk a little bit about were these publicly available and how you obtained them and how they were distributed across different states?
Okay.
Okay, go ahead. We have different data sets, like 3 main data sets. Like one of them is policy tracker, and the other one is race tracker, and the third one is population characteristics, mostly from census. So the census data set is as of 2018. The policy tracker, it has a policy each state has, like stay at home. So we calculated from the state of emergency to the any policy the state did. So this data set is a one data set, and it has for each state. This is as of July 22nd. So we try to take all the data sets at the same time, so we don't have to have a lot of differences.
I would also say when we went into this, we were really trying to get information at a zip code county level, but it was very challenging to find that information.
Yeah.
Most of the information that is being put out on COVID is at a state level. So we actually had to roll back up and do the analysis at the state level, because it really did give us the breadth of doing the cluster analysis. With the cluster analysis, we wanted to have a lot of data to throw at it, and then allow the cluster to guide us into telling us what the metrics were and what the features were that kind of were related together.
Yeah, I think New York Times is the only one providing county level data, but not at policy level.
Correct.
Thank you.
Correct. You're very welcome.
Challenge, I think. If we have more data, we can go deeper and we go analysis, a lot of analysis, but there is a shortage of data sets.
Right. And sometimes you can find it at a county level all the way down to the zip codes, but we couldn't find that same process happening nationwide. So it was in, it's in bits and pieces in different states doing maybe a little bit more, but nothing from a nationwide standpoint.
Hi, Sally Ravel here.
Sally.
Hi, question for you. So your outcomes and the insights from this are very powerful. Have you shared any of this with the states where you saw trends, or considered contacting the CDC or any, representative bodies that really might benefit from this data?
Now, Omega and I have had some conversations about how to move this information forward, but we have not done that yet. I would say that when we started this effort, we were having discussions about, you know, pre-existing conditions being more of a problem, you know, that most of the folks in the Black communities were frontline workers. But I think what we really found out in this analysis is that poverty really is the basis of all of this. And from that, all of these other things take place. So yes, I do think that maybe one of the things that we did discuss was just, you know, putting it on a road show and just having conversations with people about it and engaging that way and trying to get the information out there.
Yeah, okay, we should probably connect as well, because we have a really great a set of folks who are kind of looking at all sorts of data sets to help with this. So
okay,
let's sync up afterwards. Yeah.
Awesome, thank you very much. Appreciate that.
We're giving Team 6 a round of applause. Thank you, guys. Really interesting.
All right, thank you.
So, and then we'll just move on to the next one, which is Bits and Bytes team. So whenever you're ready, just start it off.
Yeah, we are ready. Okay, thank you. Good morning, good afternoon, good evening to everyone. Thank you and A Cloud Guru for this amazing opportunity. We are honored to be here today presenting our project. Now I want to tell you about our project. It is called COVID-19 SARS B-cell epitope prediction. As Thor said, we are the Bits and Bytes team. The members of this great team, we are 5 in our team: Nisrin, Sahil, Bala, May, and they are connected from India, from different cities from India, and I'm connected from Milan, here in Italy. So it was amazing to work, trying to connect people from different parts. And we learn a lot, not only about technical skills, but also soft skills. So thank you so much for the opportunity. Please, next slide. Our problem statement and solution is, please next, estimate the epitope region of SARS-CoV-2, the spike protein. To understand what is this, it's like, as you can see in the down part of the screen in the right, it has like legs, little legs, and the spike protein is each of these legs that causes the coronavirus. And the other thing is to classify the peptides into 2 categories: the antibodies with inducing properties, the positive ones. These are the candidates that will be useful for develop the vaccine, and the antibodies without inducing properties, that they are not useful for develop a vaccine. Our solution was to automating the prediction of the antibody valence of SARS-CoV-2 data. This was to give a big thanks to Johnny Isaac, a PhD in biotechnology, who helped us to understand all this. And please, next slide. The highlight of social impact in the aim is to decide of the vaccine performance with the outcome of our model, and to save, the other is to save time to predict the B-cell epitope. And this is why we build this machine learning model. And for the future, it will help in different scenarios with high quality outcomes of the data, because this model can be used for different values in the future. Please, next. About the technologies and the model involved, we use Python and with all the data science libraries. And we use the Streamlight to develop the app, and we deploy our project on AWS using the EC2 in this case. So the model that we need to develop our project was a classification model. So we use the lazy predict library to understand which model will be the best, and the best metric was from the extra trees classifier. So we go for it, then we develop this model that help us to understand if we can help or not to the biochemists, giving them the information that they need. So now TANMate is going to help us showing a demo of our project.
Okay, so we have a small demo of our project for you. So, so we have made this simple web app using Streamlit. The UI is because of Streamlit, and we have simple input values to give. And when we enter these values, we have a predict button at the bottom. And when we click the predict button, the outcome is displayed on this web page. So it's really simple to use, and I hope it will help for the biochemist. And the next steps will be delivered to you by our teammate Nisreen.
Good afternoon, evening, and morning to all respected judges and everyone present at the Zoom meeting. My name is Nisreen, and I'll give you more information about our next steps. As there is always a room for improvement, so it is in our project. We have a plan to search more data. As more data, if we have each of our independent variables, we can have a cleaning and testing data set to be more representative of the original data set. We will lead to a better cleaning and performance of our model to give a best output for unseen data. We can also do something like hyperparameter tuning, which we have gone about, and training on another model to find if there is another model to give better performance to our data. We have also tried to develop an app with Python Streamlight, and we were not able to complete it fully, so we are planning to complete it properly and deploy it for biochemists to use it. Actually, we plan to work on a project to detect whether social distancing is being maintained or not on a live video of people on the street. But we found that we require more time to complete that, and so we switched to this project of B-cell epitome prediction. And so we have this social distancing project also left for us to complete. Next slide, please. The reference. We have taken our dataset from the Kaggle website, and our dataset is based on the paper, this paper given in the second link. The third link refers to the YouTube video where we learn how to deploy an ML model on web page using the Python Streamlit. And the fourth link is about an article on the media where we learn how to deploy the Python Streamlit app
Is there anyone that has a question to Team Bits and Bytes?
I have a question, but I can go next.
No, just ask away.
I haven't seen the results, or maybe I missed it due to audio. So is there, I know the Kaggle dataset was used, but I haven't seen the slide. Maybe I missed it with the results. What was the accuracy or the outcome metrics that were used?
Yeah, hello.
Yeah, can we just run once more the
Hey, Nisreen, you might not be able to see the chat, but we're having a bit of a hard time hearing you. So if someone else from Team Bits and Bytes could answer, that would be awesome. Demo looks great.
Perhaps if there's not another teammate that can take the question, you could pull up a Google Doc or just answer quickly in the chat. We can see your screen. We're just not getting the audio through at the moment.
Okay, please, I'm going to share my screen. Tor, may I? I'm Giovanna.
Yeah.
Yeah, go ahead and share your screen.
Okay, thank you. Okay, we have it visible for you?
Yes, I can see it now. Thank you.
Oh, thank you. Sorry, because we had some technical problems here. Okay, so we use, as I told you, we use the extra tree model, classifier model, and we use in this case for the score, we use different. We use the row out and the F1 score. Here we have the F1 score of the model prediction. This was our score. And then we got the rock and our score of 0.8060. So we got this was the highest F1 because we tried with other models, but with this model we got the highest result. I don't know if it is enough to answer your question, or maybe one of my teammates can continue.
No, this is good enough. Thank you.
Thank you.
Okay, then we say thank you to the Bits and Bytes team. Really, really interesting. Round of applause.
Oh, thank you.
So we'll be moving straight away then over to the next team, which is Hack Elite. So once you're ready, just start up and present and blow us away.
Hi everyone, I'm Neha, and my other team members are Jasmine and Joseph, and we're Team Hack Elite. Next slide. So the problem that we're trying to solve is the shortage of hospital beds faced in areas with increasing number of COVID patients. So the reason why we think this is an important issue is because the shortage of hospital beds can result in inadequate treatment received by patients, resulting in increased number of fatality rates caused by COVID. Next slide. So our solution is to predict the hospital bed utilization rate. Next slide. Hospital bed utilization rate is essentially just the percentage of hospital beds that are currently being occupied by patients. So what our model does is that based on the current COVID patients, the number of COVID patients, the number of hospital deaths, and the total number of available beds, it predicts the percentage of beds that would be utilized by patients. Next slide. So in terms of usability, we believe that this model can be used by hospitals to better predict and prepare themselves in cases where they expect an imminent surge in the next coming months. So if they believe that the hospital utilization rate is going to increase, they can perhaps order more beds and prepare themselves better. My friend Jasmine will explain further on how our model works.
So for our model, we went through the standard machine learning solution lifestyle, which I'll go over on the next few slides. First step was obtaining data that kind of had what we were looking for, which was hospital bed utilization and coronavirus data. So for coronavirus data, we used the New York Times data set available on the Amazon Web Exchange. And that data contained the cases and the deaths by date. And it also had the data by county and state level. And for USA hospital beds, that has the bed utilization rate we were trying to predict, and that was also available on county and state level. For data preparation, we went through standard data processing procedures. We dropped all the relevant columns. Most importantly, we grouped our data by state and county because in the US, each state is further subdivided by county. And that's kind of the level we wanted to look at, and also for a more regional approach. So we merged those two data files into one, and we made sure to remove any missing values that could have been due to lack of hospitals or licensed beds in specific counties, which is possible. We did data exploration, and one of the more important data exploration that we did was our correlation matrix of all of the variables that we included in our model. So our model consisted of number of licensed beds, number of staff beds, ICU beds, adult ICU beds, pediatric ICU beds, of course the bed utilization rate, average ventilator use, cases, and deaths. So as you can see here, overall we had pretty high correlation among all of our variables. Although there are a few places like bed utilization and deaths and pediatric ICU beds, which had weaker correlations, but those could be explained due to the fact that at the time of this data, most of the cases were probably going to be adults. For our model building, we split the data into train, test, and validation sets, and we went on a 60-20-20 ratio. We stored our data on the AWS S3 bucket, and we immediately went to work using SageMaker using the regressor algorithm that is currently available since we were going for hospitalization. We evaluated our model using the mean square error. And as you can see here, we had a pretty good one for both the test and the validation sets. And most importantly, our model was able to predict using all of those variables that we included. So I think that for us was just kind of a really big thing. Our applications, so as we stated earlier, we can use it to predict bed utilization rates as they're related to the number of cases. Our next steps would be possibly creating an app or dashboard for government officials, administrators, or anyone who wants to be ahead of the curve so that it can aid in their prediction of if where they live on a county and state level will be the next hotspot or if there are some things they need. And also for next research steps, we want to focus on ventilator usage, as well as other hospital equipment and resources such as staffing that will be needed to treat possible surges of COVID-19 patients. And that is all.
That's super great. Does anyone have any questions for the team?
No questions, but if I could just add one compliment, I actually loved seeing the instance type that you selected. Like you got really into the details, and I wanted to highlight that part. It's something I really enjoyed.
Yeah, I'd +1 on that. I thought how you kind of walked us through the steps and the stages that you took gave a really good background to your process and how thorough you were.
Okay, great. Then another round of applause for the Hackathon. Really well done. And then we'll proceed over to the next team, which is the team named Adele Goldberg. Ready when you are.
I'll start then. Here. Let me see. Can everyone see the screen?
Yes, I can see it.
So let's start.
Okay, so hello everyone. My name is Sophia. I would like to thank WWCode for the opportunity. I'm going to start a presentation for our project where we create an app that incorporates X-ray image classifications to fight both COVID-19 and antibiotic resistance. So first of all, I'd like to introduce my team. The people who belong to the group are Yasmin, she's based in Canada. Myself, Sophia, I'm from Brazil, but I'm based in the US. Ravi from India, and Marie from the US. And we also had Shreya assisting us with medical advice. So talking about our problem statement, it goes back to 2013 when the World Health Organization declared antibiotic resistance as a global threat to public health. And one way to fight it is optimizing the use of antibiotics by reducing unnecessary use. However, in 2020, the COVID-19 pandemic may worsen the crisis, with doctors heavily overprescribing antibiotics, even when the patients do not present signs of bacterial infections. And searching why this is happening, we found out that COVID-19 definitely increased the degree of uncertainty in healthcare service. So with this problem in mind, we created an app for healthcare professionals' use. It has two main goals. The first goal is to assist in the diagnosis with a deep learning model, which classifies X-ray images into 3 medical conditions: COVID-19, bacterial pneumonia, and normal. And the second goal is to increase antibiotic resistance awareness in healthcare locations through education tests and institutional guidelines. Now Maria is going to tell us about the social impact of our solution.
The World Health Organization strongly advises against using antibiotic treatment to treat coronavirus due to the risk of increasing antibiotic resistance. Around the world, 700,000 deaths each year are caused by drug-resistant diseases. Unless we take action, this number of global deaths could increase to 10 million by the year 2050. By empowering healthcare workers with tools to distinguish between antibiotic and viral infections, doctors can avoid prescribing unnecessary antibiotics and provide patients with the best possible treatment. Next slide. With our app, we hope to supplement the decision-making of healthcare workers by providing them with tools to assist in the diagnosis of a patient and make better informed decisions. In addition, we hope to reduce the emergence of antibiotic resistance as we continue to fight COVID-19. And now Ravi will discuss our model.
So coming to the modeling, the first and most crucial aspect of the modeling process is the data preparation. In order to get realistic test set results, 2 key problems we addressed were avoiding data leakage between trained test and validation sets, and also ensuring that all 3 of them follow the same distribution by using stratified random sampling. Okay, move to the yes. So for the modeling process, a 120 layer DenseNet pre-trained on NIH-CC dataset was used and fine-tuned on our dataset to perform 3-class classification in order to categorize X-rays as having normal COVID-19 or bacterial pneumonia condition. The model was created using AWS SageMaker and trained using ml.p2.x large instance. Okay. So these are the statistics showing the model performance on the final test set, and the numbers signify that model is in good shape and generalizes well on X-ray images it has never seen before. And now Yasmin will discuss about tools that we use.
Thank you, Robbie. So the tools that we use for modeling and deployment were AWS SageMaker and Amazon S3. We used Streamlit and Heroku for fully deploy our web app. And finally, we shared all our code and work onto our GitHub. So here, as I mentioned, it's already deployed. So you can play with it using this site. I'll be just playing the video. So as you can see here, the very first page of the site, it shows how antibiotic resistance happens with a diagram from the CDC. And as you scroll down, there's information about how to prevent and control the spread of antibiotic resistance in health professionals and policymakers. And we got those information from the World Health Organization site that you can click from. Now you can select the X-ray images. So here we have pneumonia bacterial. So here you can see that there's 99% probability that it's bacterial pneumonia. And we have a link to antibiotic resistance hashtag in Twitter. Now we go to a case that has COVID-19. And here we have 97% probability that you have it has a COVID-19 problem. The same goes for normal as well. And there's 97% probability that it's actually normal. Okay. And next up in our steps, we want to actually improve the interpretability of our model. So by using technologies such as GradCam that highlights important regions in the image for predicting the concepts. And we want to change our Heroku service to AWS services because we saw some glitches in the Heroku service. We want to collaborate with other medical professionals to improve the antibiotic resistance guidelines in our website and adapt it accordingly to our regional policies. And finally, we want to further use our application to diagnose other types of pathological lung diseases. Thank you for having us. And here we have our our GitHub account. Thank you.
Then we have to thank the team. Is there anyone that has any questions?
Yes, Sally, I have a question. Sorry.
Go ahead, Sally.
Yeah, sorry, you went a little bit fast. I didn't really understand the link to Twitter and the Twitter hashtag. Can you just run?
Yes.
Can you just explain that, please? Thanks.
Sorry about that. So we have just a link that actually goes to the Twitter platform with the hashtag antibiotic resistance.
To do what, though? To perform what function?
So that's the idea of this hashtag is to, if the person wants to know what's the last news on antibiotic resistance, Usually people go for social media to see the latest news.
Okay.
So that was the idea, to link the latest news in Twitter with our app. But of course, we can adapt according to the local region. And the institution is going to use the app.
Okay, thank you.
I wanted to note that I used to work for General Electric before I joined Amazon, and antibiotic resistance always came up. So I think this goes beyond COVID, and it will be interesting how the team takes the next steps on this.
Well, as somebody who just had a really terrible allergic reaction to an antibiotic that it turns out I didn't need, this one was near and dear to my heart. But my question is, and apologies if I missed this early on, as part of your research, did you discover how often these lung diseases are misdiagnosed by doctors without any sort of model like this, and what level of improvement this would be over what sort of the normal is?
We didn't. We did actually talk to a professional. Let me see if I can. Yes. So we did actually talk to Shreya, a physician, and in the UK, and she didn't mention specifically how much it misdiagnosed, but she did say that they do work a lot on doing a holistic approach into finding what your condition is. And when we kind of talked about how could x-rays help in diagnosing, she did confirm that it helps in assisting in their diagnosis. So that is a good step to improve how they diagnose their patients.
Thank you.
Super great. So again, we gotta thank the team Adele Goldberg for their interesting presentation. It's really interesting. So for our next team, we are going to move over to Ada Lovelace. So you can start when you're ready.
Hi there. Can everyone see my my screen?
Yeah, looks great.
Okay. I'm Arias Hathaway, and together with Sophia, Hugh, Gabriella, and Fiona, we're Team Ada Lovelace. In my home state of Texas, we first experienced COVID-19 stay-at-home orders in March, and since then, the state has reduced social distancing requirements, even as the number of cases increased dramatically. Communities across the world have been faced with the disruption of our most basic routines with the arrival of the pandemic. Mundane errands like a trip to the grocery store now carry the risk of placing individuals at the virus's front line and introduce a level of danger to every activity outside the home. We identified the need for people to understand how to navigate the constantly evolving landscape of COVID-19 in their local community. We want to know how we can utilize current information about behavior and government mandates to understand current and future conditions of the pandemic, and then communicate that to different communities.
Our solution outlines an application called Map My Risk that shares information about COVID-19 in a way analogous to weather and map applications, forecasting the weather and sharing traffic conditions along with route suggestions. When a user enters in their state, Map My Risk provides the current total cases, new cases, and RT value, which is the rate of transmission rate of the virus in the specified state, along with the weekly forecast of transmission rates and new cases and the nationwide summary. Only transmission rate is forecasted by our model. And next slide, please. The moment a user keys in their state, the program triggers an Amazon Lambda function to hit the SageMaker endpoint in which the machine learning model predicts the RT value for the next 5 days in the user's chosen state. Kinesis Data Firehose is used in a pipeline to stream consistent predictions to Map My Risks users. The raw data is prepared and transformed before being returned to users. The columns of the dates, states, transmission rate values, and the number of new cases are consistently updated from the dataset on RT Live. After the data is transformed, a Lambda function is triggered to load the data into S3 and then into our model in the SageMaker endpoint where our model resides. The dataset is consistently ingested, transformed, and delivered to Map My Risks users for the most up-to-date predictions. Next slide, please.
So we worked with a combination of 7 data sets. 4 of them we got from the Amazon Data Exchange Service, and the 3 others came from different sources on the internet. These datasets were loaded into Amazon S3 and then consumed by notebooks deployed to SageMaker, which was easily associated with our GitHub repository. Next, please. Now talking a little bit about the data we used to train our model. So we had daily information by states about lockdown status, population, number of cases, deaths, and recovered. Also information about mobility trends, estimated daily travel, weather conditions, and also the transmission rate of the virus. That is our target. Next.
So our model uses the Light GBM, which is a boosted tree learning algorithm. It is powerful for quick, accurate predictions with dirty data, since it neither requires scaling nor formatting of data sets. And it also doesn't require the specification of the exact regression formula. Next. Jumping straight to visualizing our output, a Tableau heat map is shown here. We can hover over each state to review the predicted versus actual risk of transmission per date. Next. Taking only information from yesterday onwards, we can forecast accurately on the risk of transmission, as you can see here in the scatter plot of our predicted versus actual outcomes. Even for unseen test data in the bottom figure, our predictions fall nicely on the 45-degree line. Features that prove useful to our model are the lagged versions of risk of transmission, location, and mobility variables as shown here in our feature importance plot. Next. We repeated our model to observe how far back in time we can rely information on. As expected, the more distant the information, the higher the errors. Next. Interestingly, adding lagged weather variables as a proxy for lagged mobility improves our predictions. Next.
So what are our next steps? We can further improve accuracy through hyperparameter tuning and other means. If lower granularity data is available, we'll be able to predict this risk at the city level as well as specific locations at specific times. We can also expand beyond the US with more data. Next. The Map My Risk app directly impacts communities by providing the current and predicted risk associated with any travel. If individuals anticipate how the virus is spreading, they can modify their behavior, slowing down the risk of transmission. Next. Hopefully, with the Map My Risk app, the user will have less anxiety about traveling anywhere because she will be able to plan where and when to go in order to reduce her risk. Next. This concludes our presentation. Now I would like to address any questions you may have.
I have a quick question. This is Shahika. There's usually a delay in the number of cases versus number of recovery. Were you able to take into account that delay in the data sets when the number of cases are reported versus the recovery and or further complications happen?
So maybe I'll jump in on that. For our use case, we use information from yesterday up to 1 week ago. So we can go all the way back up to 1 week. I mean, technically you can also just lag the information, just that the accuracy falls with it. Yep. And we don't really take into account, we take into account cases and recovery, but we find that the most important variables are actually the risk of transmission. Yeah, that is calculated by RT, which also takes into account cases. But what's interesting to us is also that in the feature importance plot, what comes in as important is the mobility variables. And what's interesting is that the mobility variables are 2 weeks lagged from current date. So it kind of shows some implications of this, yeah.
It wasn't clear to me if there is a live working app right now. Just wanted to verify.
I'll go ahead and jump on this. So for our solution, we have a mock-up. So if we go back, Aries, if you're able to go back to the slide with the 2 screenshots, I believe that, yep, go down. Yep, so we have a mock-up. So we have these images, and what our model is doing is predicting the RT variable there, the rate of transmission rate. So one of our next steps also would be to take this into action and turn this mock-up into a real application. So this is just how our model could be used in the mock-up for this.
Got it, thank you.
To kind of add on that, we did deploy the Tableau map though, so it's online.
Yeah.
Okay, there doesn't seem to be any more questions at the moment. So let's give Ada Lovelace team another round of applause. Then we'll move over to the last team of today, which is the Karen Sparck-Jones team. So take it away when you're ready.
Okay, can everyone hear me? Okay, hello and welcome to Team 5, Karen Sparck-Jones. In the Women Who Code Mission Predictable Machine Learning Hackathon, we created a standardized index to categorize the risk level of COVID-19 spread in communities. Our team members are Amy Jacobs, Funke Olaleye, Hani Patel, and myself, Elizabeth Q. First, Amy is going to introduce and explain more about our project.
Thank you, Elizabeth. We wanted to create a way for communities to determine the current risk levels of running out of hospital space for COVID-19 patients. Ideally, this solution would be as easy to understand as reading an air quality index. With COVID-19 now changing its course away from densely populated areas and making its way to smaller communities, many who are struggling more each day economically, our goal was to give these communities a way to assess their current risk levels, which could result in expanding the use of face masks in public spaces and encouraging remote work. With our problem identified, it was time to figure out our methodology. The COVID-19 search by AWS is a compilation of COVID-19 research papers. A query suggested a paper by Sue and Al-Huri, which described a standardized readiness reopening index. This paper suggested using a standardized index using multiple indicators to help remove bias to determine a daily composite index. Their methodology was well written out, and we agreed that a standardized index would be beneficial in a time when we are being bombarded with various COVID-19 statistics. We needed to find data sets that would give us the following indicators: the positive cases, infection rates, the mortality, hospitalizations, and testing capacity. After searching through the AWS data exchange, we found that if we wanted to implement our model, it would have to be at the state level. The data sets that we ended up using are from the COVID tracking project, the state level, and REARC's US hospital beds, which gives us the total state hospital bed and ICU bed counts. We were then able to relate the hospital bed data with the state data using FIPS. We ended up tossing a favorite data set, the IHME, from the AWS data exchange because it contained too many null values and we couldn't find a county level data set that included the indicators. Next, we dropped all the unnecessary columns from our data frames. We had initially included negative cases, but quickly found it correlated with the testing capacity, and the negative cases could be dropped. We were able to follow the model described in the paper utilizing AWS SageMaker with Jupyter Notebooks and AWS S3. We implemented the readiness reopening index model, and it was exciting to see all the pieces build upon each other to produce the composite index. Next, Funke will continue our presentation.
Hello. Thanks, Amy. Here is a result based on the 5 indicators earlier mentioned, plus one more. We added ICU bed capacity using this indicator to come up with a daily composite index as displayed under the red arrow. The composite index allows users to compare a given state performance over time. Its value ranges from 0 to 1, where the highest value corresponds to a higher level of risk. Clearly, we can see that New Jersey is more prepared and ready for reopening than Alaska. Next. The paper suggested using the model as a comparison tool. On the day we first managed to get the model to run, many news articles were stating that COVID cases were starting to level off or were now on the downside, the down curve. Alaska was reporting a daily composite close to 0.9 during this time, and North Carolina was about 0.89. Looking at the news report, it didn't match what we are seeing in terms of the risk level associated with reopening. Next. As our next step, we want to split and train our input data at the FIP level, which is the state level, for more accuracy. We also want to compare with other learning, linear machine learning model to select the best model. In addition, we want to use cross-validation technique for evaluating the machine learning model by training several ML models and maximize model performance. Next. The aim of this is to limit the number of hospitalization, not to overwhelm the healthcare system in any city or state. The standard index can help decision maker in hospital project and adequately plan for hospital beds, help healthcare provider to predict additional needs and proactively prepare healthcare services. In addition, state and local government will be able to make informed decisions. That's all we have for you. Thank you, and we hope you enjoy the presentation. You can always take a question if you have questions.
Okay, thank you, Karen Sparck-Jones. So I'm looking at the time. We have time for 1 or 2 questions. So if there's anyone, then ask away.
If that's everything for now, then that's all of our teams presented. Oh, sorry, I'll throw on my video. Hello. So the judges and myself and Sapphire are going to break out and deliberate. I guess this is the verb here. But Helena, are you on camera yet? She is one of our track leads in data science, and she is going to lead you all in a quiz. Well, we break out. So you all are going to stay in this room, and Thor is going to be here to help you. And we'll be back in a little bit.
Great. So if the judges are a little bit patient with me, there's a lot of names here, so I'll sort every one of you out and put you into the room. And Helena can take it from here.
To jump on.
I can definitely jump on. Hi, everyone. My name is Helena Bormer. I am one of the track leads at Women Who Code Data Science, and just big congratulations to all of the teams. This was so amazing. I was just swept away by what you have built and what you have done for this short time, and everything was really, really amazing to see. So huge congratulations, and I hope to hear a little bit as well, like how was the experience of just joining in for this hackathon. So I have a little poll, just to, not a poll, but a quiz for you all. So I'm going to launch it, and this is just so you don't just sit and wait and you're really excited and you're really nervous. So I'll launch it now. Can you let me know that you're seeing it? You can write in the chat, or you can just turn on your microphones and tell me if you're seeing it. Perfect. So this is a little bit about Women Who Code, some statistics, a little bit about AWS. I think all of you are much more, you know much more than me about that, because you're doing so many amazing projects. So you can just if you want to answer the questions while we're waiting. And this is not a competition, so this is just for fun. So just have fun with it and see if you know anything of this. So yeah, I think you can see it. In the meantime, it would be so amazing if anyone from one of the teams would like to share when you have done the quiz or just in between, what was it like to be in this hackathon? Like the best thing, I mean, I can just see what the best thing is, just connecting globally and working together with amazing projects. That is, of course, something that's really, really cool. But if anyone would like to share their experience, you're welcome to do that. You can just turn on your microphone or let me know in the chat or anything if you want to.
Yeah. I would like to share my experience, Elena.
Is Giovanna? Yes?
Yeah.
Hi, where are you from?
Yeah, I'm Italian Peruvian. Now I'm based in Milan. I'm always part of your events.
Oh,
I
yes.
love your events.
Yes.
Yeah.
So cool to see you here.
Yeah, I'm so excited of being part of this final round. And I have to tell that it was an amazing experience. We, all the members of my team, we met in a 5 weeks data science bootcamp. All of us, we are beginners in data science. So for us, this like, wow, it's really awesome to be here today. Thank you for this opportunity. And I'm so proud of my team. And I want to tell them that we did a great job. And well, with all these teams that are amazing, all the best for teams, because we have learned today many technologies because you have shown amazing project. Thank you so much to Women Who Code for the opportunity.
Thank you so much for sharing this, Giovanna. And I know you from the chat in our webinars. So we've been talking there. So amazing to be here and to say hi for real. And I agree. I mean, I think it's so amazing that you can really see like meeting here at Women Who Code, joining in for the boot camps, connecting, and now you're here doing this hackathon. I mean, how amazing is that? That's just so wonderful to hear, and thank you so much for sharing. You should all be proud of yourselves for just going through this and doing this, and it's just, I'm really excited to see the winning team, but the presentations were amazing as well. Really, really good. So anyone else who would like to share what was the team experience all about? What was it like being in a hackathon? Was this your first time? Have you done it before? If you would like to share, that would be so cool. I can see that you're starting to answering the questions. So I'm not going to end the quiz yet, but I will share the answers in the chat later on as well. Anyone else who would like to share their experience? Anita?
Hi, yeah.
Hi.
I didn't participate in the hackathon per se. I had other conflicts, but, and I've been in the industry, I'm like 20 years in the software industry. I did fuzzy logic programming 24 years back in my undergrad. I just want to say this community you have built, this is so awesome and so essential. Now I have a daughter who is in the tech field. She's a third year student at Duke. And I think this is going to go a long way supporting the young women as they grow in their careers. So thank you for that.
Thank you so much for sharing this, Anita, and good luck to your daughter as well. We hope to see her as well in the community and maybe together. I mean, how amazing is that to be able to have a common interest and everything. But I agree, it's a really amazing community. I joined this year, and I think it was last year. And I feel like this is one of my favorite places to be, where I feel encouraged and just you know, it's just encouragement, helping each other, feeling that, you know, all these webinars and fun things happening. It's just so much fun being a part of. So
exactly. And I saw some of your questions, so I'll share a little bit again. Going back to my undergrad, we were 2 girls in our class. And my friend, the only other person I knew who did computer science coding with me, she left the industry within like 2 years. So having a community where, you know, you all can come with the shared interests and support each other, I think that's very essential. Thank you.
I couldn't agree more. I think this is one of the strengths of being this community, to actually, one point is actually feeling I can do it. I mean, sometimes people ask like, oh, can I really take the leap and do this? And then when you're in the industry, when you're working, to actually feel the motivation and have the strength in the community to help each other forward and just stay and also just doing things together. Everything from if you're just a beginner to if you've been in the industry for a long time, doesn't matter. We can all come together here and work on projects and have fun together. So it's just really amazing. So anyone else who would like to share? It's so much fun just hearing from you what you think. Like, even if you didn't participate in Hackathon, just what is your experience? Have you been doing the webinars with Kesha or anything? Would you like to share?
Okay, my teammate
Sharonda?
Omega is, yes.
Hi, yeah.
Hello, my teammate Omega is pushing me up here, so I'm going to do it. But Kesha, I would have never thought about doing this if I hadn't participated in your workshops earlier in the Women Who Code conference that you were a part of. I was very excited after I attended your workshops. Omega and I actually attended Flatiron's school for data science. We had just graduated, and then after I finished your workshop, I called her up. I said, hey, we got to get in this Codathon. And I'm very excited. This was our first, and we certainly did enjoy it. We learned a whole lot. It was a good effort for us, and I just wanted to say thank you again for inspiring us. Appreciate it.
This is so amazing to hear. I mean, I feel like I get goosebumps just, you know, from this energy in here and what you've been learning, what you've been sharing, and just completing, the boot camp as well. So congratulations to that, and just being it, just having actually the guts and like, okay, I'm going to participate in this hackathon. I mean, it's not something, maybe, I mean, I remember when I did my first one, I'm like, oh, can I do it? But then when you do it, it's so much fun and you work together and you meet people. And now we're here and sharing this moment together and waiting patiently as well. So I hope you feel excited and let's just celebrate each other for all the hard work, for all the cool projects. I hope you continue to work on them no matter what, because they were so cool. So I really hope to see them just evolving. Please share in the Slack channel, like if you're continuing as well. That would be really awesome. Anyone else? I think someone else turned on the microphone. Would anyone else like to share how the experience has been or anything else?
Hi.
Hi.
Yeah, that's me. Sorry. Yeah. I'm really glad that I joined. This is my first time and in any hackathon. But the Women Who Code, actually, I've been following for quite some time. And one of my colleagues in my company was very actively involved in it. So I didn't really realize that until I started the boot camps and she was going through it. And then I asked her how she, got into it. And right now I'm totally into data science and machine learning. So I'm all the time on LinkedIn doing any type of course that pops up related to the idea. So I'm making a lot of connections that way, and I'm really finding it, very dynamic. And honestly, I wish this type of support system was there when I had a break in my career some time back, and it was really difficult to come back to work without that level of support from the community. And at that time, one woman friend who was working in a startup, she just referred me to the people there, and I was volunteering, and that kind of gave me such a boost in the confidence and call it law of attraction or whatever. But after that I got a real job, and since then I've been working, luckily. And it is really not easy for women who have taken a break in the career to break back into this Bay Area's tech work sector, because it is the the world's tech capital, you can say, right? So there are and of course for people who are in their mid-career level competing with college grads, it is a really big deal, and we have to constantly evolve. And honestly, these type of boot camps and openly sharing of information by especially with women, it's really, really energizing. And thank you all so much for what you do. Really appreciate it.
Thank you so much for sharing that. I mean, so openly, and just I feel even more like it's just so happy to be part of this community with all of you, and that we can actually share and continue to encourage each other like this. It's just really amazing. Anita, would you like to add something in?
Yes, I would love to.
Yes, go ahead.
Yeah, thank you for sharing that. I could not agree more with you. And it is not just the Bay Area, it is everywhere. And so the big question on my mind for some time has been, how do we change this? We talk about women in STEM and girls in STEM a lot, and I've been involved with many of these forums over my career. We talk about getting our girls in STEM, but at this time, what I'm most afraid of, now I'm talking as a mother also, that are we setting them up for disappointment later? So I strongly feel we need to do something about it. So if anyone ever has ideas, I'm listening to however we can solve this problem.
Yeah, definitely. I think one conversation we are having internally in our company is also, it's a big taboo if you have a break in your career. Especially for women, it is a given, it is a natural thing, especially for Indian women, I would say more than anyone. We have dealt with it anytime and every time. And so it is very, unless you have that support system, ecosystem of support within your family or friends, especially when you are here and for a first generation immigrant like me, or I'm sure you probably too, you don't have that kind of support system. My parents are in India, they are old, they cannot come here for me to, support me when I need to, take some time to do my college work or anything that I want to pursue. And it's difficult. The whole idea behind how you look at recruiting. So right now it is more of the focus goes on to, the college grads, and that is all good. I'm not against, hiring diversity. Everything is good, but we have to also consider people who have brought in so much value for so many years in this tech sector, women especially, who with a lot of obstacles that they have overcome with no support at all on their own, they have to be recognized and appreciated and elevated and kept at a different, pedestal, I would say. And the criteria for determining their meritocracy should be how hard they have actually gotten, what are the obstacles that they overcame, rather than, just looking at the tenure of what they did, or even what they did, given what circumstances has to be included in that story when we have a conversation with the interviewers, I believe. Yeah.
I'm totally with you. Hopefully we'll do something. And I feel it's our responsibility to the next generation, because the women should not have to choose between career and family.
Absolutely.
It should, it should not
that
be.
Is that is a whole different arena you're getting into. Yeah, but thank you.
We'll take that offline. Let's connect offline.
No, this was so good. I just thank you for sharing this, and I hope that I can't remember who said, but that we need to do something to keep women and girls in STEM and women in tech. So we have the Slack channel. Please share your thoughts, share your ideas, get together, just support each other, work on projects. If you have, anything, just share it. It's just this encouragement we have from each other. I'm just going to end the polling so you can see. I hope you can see the results.
The questions you had, that goes right into our conversations.
Yes, exactly. So I'm just going to quickly, because the judges are not back yet, so let's just quickly go through. So members of Women Who Code, 230 plus. Okay, there's two members in Women Who Code, the global organization. That is amazing. We are part of that. Isn't that really, really cool? And then Women Who Code is located in 70 cities. 70. How amazing is that? And even, I mean, better and really cool is that Women in Code run 1,800 free events every year. Imagine that. I mean, this is one of them, and it has been a few of them just recently. And then to the part where we need to encourage each other, that is how many women who are leaving their tech careers in the midst of their careers is 56%. That's a huge number. Like, it's just too much. We need to lower that. And then we have the online tracks that we have. So this is one of them, Women in Code, data science, and then we have blockchain, cloud, front-end, mobile, and Python as well. So that's a lot, and just other communities. If you would like to check them out, you should do that as well. And the next question is, after 8 years in the tech industry, how many women in India working in the industry will quit? And that is 45%. So again, we need to lower this. And this is your actually domain, so you know more than me about this, I think. But S3 is object storage built to store and retrieve any amount of data from anywhere. So this is the AWS questions coming in. IAM is stand for identity and access management. I did like the awesome management as well. I mean, because you're all done so awesome projects as well. And AWS was launched 2006. And one of her first hackathons ran actually 1999. So that was the answers to the little mini quiz. And you can find all this information about statistics and Women in Code on our website as well, if you would like to check that out. So now we're still waiting with patiently for the really awesome results. And anyone else who would like to share how the experience has been throughout this journey hackathon? Or just share what it was like to work. Did you work in a global team? How did you solve that? I know it's really tricky with different time zones and just getting that together. Shauna, I think you have your microphone on. Would you like to say something? No, Ravi, maybe?
Yes. Hello, everyone. I'm
Hi.
Ravi from India. So first of all, I would like to thank Women Who Code for this opportunity and all the work they are doing for the women in tech. And coming to my experience, it was my first hackathon and a really amazing experience to work with such a wonderful team that Women Who Code provided me. So it was one of the best experiences in my life. So thank you for this opportunity.
Thank you so much for sharing that. And that just makes, you know, it's just amazing. And I feel like this is why we all are here, and that it was such a, I'm so happy that you thought it was amazing. This was an amazing experience.
It's really so amazing. Thank you so much.
Cool. I hope to see all of you in upcoming webinars and boot camps and hackathons and everything else fun we do together. So throughout all the tracks. So it's not only Women in Code Data Science who do really awesome fun things. We have the other tracks as well.
Yes,
thank you so much, Ravi. Yeah, thank you so much for sharing that. So that was really awesome. Anyone, I mean, I just love hearing all your stories and your experience with this and yeah, it's really, really, like I said, someone said just crying with the feedback, you know, with the teams, talking about each other, so amazing to hear. This is really, really, really nice. Anyone else who would like to share?
Hey, Helena, can you hear me?
Yeah.
Oh, awesome. I took my headphones off. Yeah, I just wanted to weigh in, not as someone who participated in the hackathon, but I work for the Women Who Code team. I'm a program director for the team, and I just came here to support Kesha and Naomi and Sapphire, and have just been following along the progress of all of the workshops and hackathon, and everyone is just really blown away at the projects that were submitted and the fact that these projects are represented at the top of the list. There were so many that were submitted and ranked over the weekend. I know that they had a difficult time picking the top 7. I know that the judges are struggling right now to decide the winners. So I'm I'm sure that they are having a great conversation about it. But just to echo what everyone else says, I think someone said in the chat, I love all the love that is happening, and I'm definitely feeling that as well, and didn't expect to have such a emotional experience just watching all of the presentations and having everyone just encouraging each other and seeing all of the teams that were formed and across different cultures. And I know that some of you presenting haven't presented either a technical project before, or maybe this is your first time presenting in English, or maybe this is your first time presenting something on machine learning. And I just think that everyone did an amazing job, and I wish you all the very best. And of course, thank you to Kesha again for putting all this together, and it's just been so great to work with you. And Helena, you're doing a really good job at being like the time the time in between the judging. And I also want to thank Thor, who has been helping with the IT right now, is helping with the judges. But yeah, congrats to everyone.
We're such a good team in here, all of us, all of the teams in the hackathon, and everyone helping out and doing this. I mean, I feel very happy to be part of just helping out in Women Code, and we have a volunteers channel and welcoming onboarding calls for that if you're interested. It's like one of the best experiences for me ever, what I've done. So feel welcome to check that out in Slack as well. And thank you so much, Anna, for just sharing as well. So now we're just waiting. So I'm hoping someone else would like to share how the experience has been for you. I can't say anything because I didn't join in for the hackathon. Next time I will. It's so amazing with all the projects. So anyone else would like to share their experience from Thor, I think would you like to say something?
Yeah, I just want to hear from the different teams what kind of challenges you met and how you actually solved them.
Anita, would you like to share?
No, I'm sorry. I was going to ask something else. Yeah.
Yep. I really like that question. So no one had challenges. It all went very smooth, just no problems at all. Honey, would you like to share?
Yeah, I would just go with the general problem that every team has experienced is not having enough data, or data with the biased results. You know, with this COVID data, it's everywhere, but not with the there is no consistent data. And even if the data it's hard to make sure that the data itself is not biased, you know. So I'm sure everyone has experienced that. And even though knowing the limitation, everyone has come up with such solution. It's just great. So that was one of our problem. Like, we really wanted to go at this county level. The project, how we started was to support the county level hospitals, to make sure and let them know that, okay, this is the COVID spread rate, and this is your, or as per the data, this is the ICU capacity, and you are supposed to be running out of in few days, and take early actions, you know, and make maybe other hospitals or convert children hospital or something kind of hospitalization arrangement, early actions. But we really couldn't find the data, granular data, so we stick to a state level. But it would be really nice if we have a granular data, and if we can come up with some solid solution which can actually help implement this kind of matrices, you know. And I think that can make a huge difference on how the decision has been taken currently. So yeah, that's the problem. I'm sure many team has experienced this data problem. So yeah.
Thank
Interesting.
you.
Thank you so much. No, it's just the same. It's like highly interesting. Like each country, each region delivers out the information differently. Now, I am Helena's country neighbor. So, and we have some access, and we can get it down to the municipality level and region based here. But like still as everything, me coming from a digital forensics perspective, like source check, fact check, dig in, all of this. So hearing about your problems and how you solved it and how you, what more you want is like, it's really interesting. And I hope that in the future they will provide more localized information for everyone.
I agree. It's the same in the neighboring country, Sweden. So let's hope. I think, Anita, you wanted to add something in. Your microphone is on. Did you have a question?
I just wanted to hear from you. You know, how did you all come up with this hackathon and this whole program? It's always interesting to hear how something gets started and comes about.
So I am not sure if, Kesha, are you still here? Otherwise, I was not part of organizing the hackathon, so I can't answer that question. But let's see if anyone else is here who has been involved. No, maybe
I'm
not.
still here.
Kesha. Oh, hey. Hi.
But
yeah.
I missed the question. What was the question?
Kesha, I was just curious, you know, how did this come about? You know, it's always interesting to hear, you know, how the sparks fly and some things.
Oh, yeah. I can definitely speak to that. So I am a person, I believe in like continuous learning and continuous development. So I had a challenge, a personal challenge for myself to, over the summer, create a project that used machine learning to battle COVID-19. And I just had a thought one day, it would be really cool if I could take others on that journey with me. And so I reached out to Women Who Code about partnering, and the rest is history. From there, we had the 3 workshops that I taught, and then we had the hackathon, and we're here today. So that's the history.
Isn't this so cool? So if anyone else here wants to spark something like this, you know, Kesha has already shown the path, right? You can just get something like this kicked off and inspire all of us.
And I'm just I'm very proud of all of the teams, all of the people that participated in the workshop. It just really warms my heart and inspires me just to see just the level of participation. So when I first started this, I wasn't sure how many people would participate, if it was something that people would gravitate to or even want to be a part of. And I was just totally blown away. So just thank you all for participating and submitting projects to the hackathon. You've all made me very, very proud.
Yay, thank you, Kesha.
That was a great question, Anita. I'm really happy that you asked that. It was so nice to hear from you, Kesha, your perspective and just how it all started. And like you said, Anita, just to have that feeling that you challenge yourself, Kesha, and like, I'm going to share this and doing with COVID-19 data and just see where we are now. So it all starts with that little seed, and you can just plant it and it can turn out to something like this, which is really, really amazing. So yeah. Great question as well. I just love that.
I'll share another very little bit.
Go ahead.
I hope I'm not taking up all your time, but
we're waiting, so please go ahead.
Okay, so interesting how worlds come together, Kesha. You know, I don't know what bubble I was living in, but apparently I had not heard about a cloud guru until I started attending your sessions. And then the other day I was talking to another friend. So I have worked, I worked mostly on enterprise platforms, on-prem stuff. I've done AI before, but I've never pursued a cloud certification. Then one of my friends said, you know, this AWS practitioner, it's pretty easy, and I think you should look into it. And all you have to do is take a Cloud Guru's course and you'll be good. I'm like, oh, this is a sign, got to be a sign. So I'm now going through your course on that.
That's awesome. Well, I definitely wish you luck on passing that certification exam and planning out your next steps after that, because that's just the beginning.
That's just the beginning, yeah.
Yes.
And I would encourage, you know, I see a lot of young women starting in their careers here. So that cloud certification is a good one. So many essentials. So when I went to school, I learned all those fundamentals, very tough way. But now I think Amazon and all the cloud architectures, they've made it so easy. So ingrained in their solution, it's good to get one of those certifications to know those.
And good luck with the course, Anita.
Thank you, Kesha and Helena.
I think someone else started talking. Not sure if I just talked. No, maybe not. I don't think so. So we're still waiting for the excitement. Let's see what happens. I'm thinking if anyone would like to share. So one thing that I want to know, would you participate in a hackathon again after doing it now? Or if yes, Hani says yes. Anyone else? You can answer in the chat, or if you want to just turn on your microphones, that's okay as well. Absolutely, yes, yes. No one has been scared off from doing this. That's really cool. You shouldn't be, because the projects are really, really amazing. A lot of yes, yeah.
Oh,
yes.
that's a good a lot of yeses.
Yes, it's really amazing.
I'd love to share something just from my own team. So,
yes.
Before this hackathon, my team and I, we were friends and we all work in the industry, but we hadn't worked directly together. And even after this hackathon, we're gonna form like a bit of an informal code club, just the five and a couple of others, to keep on working together and do projects together. So not just hackathoning together, but encouraging each other to keep on coding and do side projects and things.
That is so amazing. Thank you for sharing that. And I think that's just one of the things when you get together like this, just working on something, and you end up maybe do a study group or a meetup group and projects, and just continuing that great teamwork. It could be with other projects or hackathons, whatever it is. And someone else is, Arias, you're doing Austin's Diversity Hackathon. Really cool. Good luck with that as well. Would you like to share? You don't have to.
I don't
yeah,
know
go
much
ahead.
but I did just sign up, and so I'm looking forward to them like coming out with new information. They've done it a few years previously, so yeah, I'm excited to find out what all goes into it, and I definitely feel more confident going into that one, having just kind of seen what this one was all about.
Even better, right? Just to have a little bit like done a little bit of presentation and how, I mean, I'm not sure, was this your first hackathon, Arias?
Yes, it was. Yeah.
Okay, so yeah, then it's even better, because like you said, if you take the first step and you do it, and you actually realize it's not as scary as I thought. Like, you're building up a lot of things, like sometimes inside of you, like, oh no, this is going to be scary, I don't know, and maybe I'm not, qualified enough. But in a team, you need all the skills, and it's also from beginner to experienced, and just to learn from each other. And even though you're a total beginner, you can actually teach someone who's very experienced because you're coming in and seeing stuff with new eyes. So never let that just stop you. Just take the step and be ready to just learn. That's what it's all about. So
yeah, definitely the support of the team really made a difference with this, and I had no idea what to expect. And so it was just a really great experience learning and like getting that support and community. So yeah, thank you so much for everyone that participated and helped put this on. Thank you.
Thank you for sharing that. That's really just loving to hear all your stories. Sapphire, I think you want to go ahead.
I just unmuted there. So yeah, everyone, congratulations on the presentations. They were absolutely fantastic, and the judges have now finished. And it was a very, very tough decision. Really, really was. So, but before we announce the winner, we're going to have a group photo. So whoever wants in the group photo, we'll give you a couple of seconds to get ready. And if you want to be in the group photo, just turn on your camera. There we go. I see people's cameras turning on. There we go. Okay, that's everyone. I can see my screen anyway. So I will give you a few more seconds to get ready. There we go. Okay, so 3, 2, 1, cheese. I would have put my hands up, but I'm like using the command shift forward to take the photo. So we'll do one with the hands up. Okay, let's go. 3, 2, 1, cheese. There we go. Awesome. Okay, Kesha, are you ready to kick off?
I am here. Yes, I am. But I'm still trying to find out who the winner is. So give me 1 second.
It should be in the, I think we put it in Slack group there, Kesha, in our group chat.
I'm happy to share a few words while we're pulling all of it up. Also, Sapphire, I sent you a private message on Zoom, if you could check it out for one quick sec. Okay, so as with many hackathons, the decision was extremely close. This is a judging panel that stretches across many different fields and disciplines. We have deep tech, we have deep UX, we have deep social impact. We even had someone who worked on the Amazon COVID response team. So everything down to medical details was something that I learned. Thank you, Sapphire. I see it coming, just as a heads up. So again, like I want to share a couple things that we're gonna do after this, because the innovation, the work, the social impact does not end with the hackathon. I know that we were only able to pick one winner, but what we wanted to do was certainly be able to provide feedback to all teams so that, I know virtual presentations is strange, you don't even see if we're smiling or not. So at the very least, wanting to share just really strong standout moments that all of the teams had. Another thing that we're going to be working on in addition to feedback is trying to make introductions to teams that can further these ideas. So this is something that we're going to be working on. There's no guarantee, but we do want to be able to provide that additional feedback on everything from UX to working with SMEs to diving into these use cases. So that is something that we're going to be working on. Again, it doesn't stop here. So as we're, calling out like Adrian, Sahika, myself, Sally Ravel, the judges just had a fantastic time talking about these. And if Kesha can give me like the thumbs up that I'm able to announce the winners, but Kesha, you kind of did all of the upfront. I feel even strange being the person to say the winner. Did you want to take this moment and share?
Sure. I would love to share the winning team, the Architechts. Congratulations. Great job. And I will reach out to you on the Women Who Code Slack. I have the codes for your $5,000 credits and the codes for your 1-year free access to a Cloud Guru. So congratulations. Job well done.
Claire, Mary Jane, Norman, Chloe, Claire, you guys are phenomenal. I just want to make sure you guys heard your names said as winners, but frankly, all of you guys are winners. I have so many notes. You guys are incredible.
You guys, that's absolutely incredible. That's incredible.
I'm speechless.
Very, very cool. Very, very cool.
Yeah, thank you so much.
Thank you so much for your time. This is brilliant.
I know, and I'd just like to say as well that going into this, I was thinking about what I wanted to do for my final year project in university, and I was thinking about going the machine learning route, but I wasn't sure if, I didn't know if I'd had the confidence to take it on, and this gave me, even without the win, it gave me so much confidence, and I'm really excited to go in and start that project now, so thank you all so much for putting this on. It's been really incredible.
I got goosebumps when I heard K and N. All of you guys are, please continue to crush COVID, as Sandy put it, and continue to put your passions toward machine learning. We loved it.
Thank you so much.
Thank you.
Yeah, massive congratulations. Oh wow, your project was absolutely fantastic, and so was all the projects that was submitted. But yeah, can't believe it. Go Belfast. Kesha, do you have anything else to say before I do the Women Who Code closing?
I just want to say congratulations to the architects, and just this whole process has been very inspiring for me, just to see the level of participation and all of the amazing projects. You guys, I feel like crying right now. I'm just so proud and just so happy to have been a part of this. And that's all I have to say. Congratulations.
Okay, so I'll start off with sharing my screen then, do the closing for the event this evening. Okay. Everyone see my screen okay? Cool, okay, awesome. So yeah, congratulations everyone. Yeah, so we would absolutely appreciate it if you could give us feedback for all the participants that were involved in the involved in the hackathon. We would love to hear your thoughts throughout it, and so we can improve in the future. So Naomi, if you could paste that there link into the chat, that would be great. Thank you. And a big massive thank you as well to Claire Houston, who's our new volunteer she actually is one of the winners in the Architechts team. So yeah, she actually created this feedback form. So she joined the volunteering team last Wednesday. So thanks Claire for creating this form. And yes, a big congratulations and applaud her to all the teams. I'm mind blown. I went through all the projects last weekend and I was just so proud of everyone. So a big massive applaud her. And thank you to Archana, Bree, Helena and Aram, who took their time out last weekend to help Naomi, Kesha and I judge as well. So thank you so much. Applaud her to you all. And Shauna, who's our Global Leadership Director, who has helped support Kesha, Naomi and I throughout the last few months as well. So thank you so much, Shauna, for all your support. Applaud her. And my big, massive, obviously, Kesha, you have been so amazing. So thank you so much for all the hard work you have put in for running the workshops and the hackathon as well. So thank you so much. Applaud her. And Helena as well today for hosting the quiz while we were hosting the poll while we were in judging with the judges as well. So thank you, Helena. Applaud her. Congratulations. Thank you. And of course, to Tor, who has been so much support for us. Honestly, Tor, I don't know what we would do without you, but I mean, today you have helped us so much with everything. So thank you so much, Thor. Applaud him. And thank you very much to a Cloud Guru and our judge there, Katie, and for a Cloud Guru as well for donating the prizes too. So thank you. And of course to our AWS judges as well. We have Katie, Sia Ika, if I'm sorry if I said your name wrong, Sally, Adrian and Ali. So thank you all so much for taking your time today to judge. Thank you. And of course to Sandy Carter, who was our speaker, and thank you so much for the prizes as well. So thank you. And yes, so the events is coming up next in the Women Who Code Data Science track. We have Explore Open Legal Question Answering System, and this is with LexisNexis, and this is next Wednesday at 12 p.m. EST. And you can register for this event at womenwhocode.com/data science/events, and this is a sponsored event with LexisNexis. And we have our Bytes and Brew. So this is a new event that we are bringing to the data science track, and we really can't wait. So this initiative actually came from Belfast. The team that I was involved in before I became a leadership fellow. So I was the Women Who Code Belfast director, and the whole Belfast team put this event together, and we loved it so much. And I'm super proud to bring it to a global track now. So this year event starts on the 1st of September. We're running 2 different events that day, so we can hit all time zones. So this is like a networking event where we come together to talk about certain topics that we all want to talk about, and it's just like a really nice opportunity for us to all, make new connections and great conversations with one another. And we also have our Intro to Advanced Machine Learning workshop series. It's coming up soon as well. And this is starting on the 5th of September. And we're running 6 workshop series for this year. And this will be, so definitely check this out. This is the amazing leadership team, Helena and Sumana, and also Sneha is involved in this. So definitely do take a look there if you're interested in being involved in that. And yeah, so like I said, to register for these events, go to womenwhocode.com/datascience/events. And yeah, so if you're not a member yet, do join our data science track as well. Naomi, if you could paste in the Slack link as well into the chat for people to join the Slack and also to register on the website as well. Thank you. And yeah, so if you want to follow us on our social media pages, you could follow us here on our Twitter page, our Facebook page, and also our Instagram page. And we have a LinkedIn page as well if you're interested in connecting with us on LinkedIn too. And this is our webpage in the Women Who Code website, where all of our events will be, and a little bit of background about our track. And if you want to give us a shout, like get in contact with Women Who Code Data Science track, just please reach out to datascience@womenwhocode.com, and that'll go straight to Naomi and I. So I want to thank our sponsors as well, that sponsors our track as well. So this is the Home Depot and Bank of America. So thank you so much for all the support you give us to run our track. And there we go, that's the closing. So yeah, drop the mic. Thank you very much, everyone. Thank you all for taking your time today to come to this hackathon live judging event. And a massive thank you to everyone. I'll stop
Thank
sharing.
you.
There we go.
Thank you.
I can't believe it's over now.
That's excellent.
Thank
well
you,
done for putting all this together. Thanks.
Thank you.
And great to meet everybody that I hadn't met before. Happy to help out if anybody wants to call me. Yeah, this is ANC at Amazon if I can be helpful.
Yeah, thank you very much.
Happy to do it again. Thanks. I have a Women Who Code sticker on my laptop for the last couple of years, so it gets projected to the audience if I ever do an in-person presentation again from my laptop. But,
oh, that's amazing. I'm so glad to hear that.
I think I got Adele's con a couple of years ago. Forget who gave it to me, but anyway. Happy to be supporting. So, thanks.
Thank you.
All right.
I guess if we all want to stay connected on Slack after the event, another thing that Naomi and I are thinking of doing is running an event called Data Thursdays, just to really bring all the projects and the teams and stuff together again, just so that this isn't the end. We want to keep going, so like keep the hack going. So you'll hear more about that in the emails in a few weeks' time when we get this started up. So yeah.
Okay, seems we're down to 10 participants. So I'm just going to say thank you to everyone as well. And thank you to Women Who Code, which gave me this opportunity to help out. If you ever need any help again, you know where to reach me. I think I'm still in the Slack. I won't be leaving there anytime soon. So, and Sapphire and Naomi know how to reach me. So if anyone has anything they want, then you can contact them. So yeah, thank you for everyone, and really happy to be a part of all of this. It's been amazing. Bye-bye.